Hello everyone, this is Akash and today I will be discussing about the shift and rotate instruction in computer architecture. So before starting this topic, I need to understand use very little concept about the shift and rotate instructions. So I think you may have seen this kind of operators in your C programming or any other language. So this operator actually shift operator. So this is right shift and this is left shift. Okay, so why these operators are used? These operators are basically used to perform multiplication and division by 2. So suppose I have a variable called x equals to 4, and if I write x equals to x right shift 1, then what it will perform? It will perform the right shift of x to one time. One time means it will divide 4 by 2 one time. So the value of x will become 2. Okay. And if we do the left shift, then the value will be multiplied by 2. So this is basically the shift operation. So in our computer architecture, we have our microprocessor and we have our register. So basically in the register all the values are stored in the register as a bitwise fashion. So suppose we have a value 8 and our register is or for 4 bits register, we have 4 bits register, then the value of 8 will become 1000. So if we perform right shift one time, then the value will become 0100 because we are shifting the bits one time. And you can see the value becomes this value is 8 and this value is 4 in decimal. So you can see the value is divided by 2. That's why we have this right shift. Okay, now coming to the computer architecture, we have different kind of instruction. We have total 8 instruction here. So before starting the instruction, I also need to tell you there is a little difference between logical shift and arithmetic shift, because we have these two kind of shift in our architecture. So logical shift and arithmetic shift both will do the same thing. Both of them will do the perform the operations. That means it will divide the values and it will multiply the value with 2 or divide by 2, the same thing. But the little difference is that if you perform logical shift, then it will be on the unsigned number, and if you perform the arithmetic shift, then it will be operated on the signed number. So I think you know the basic difference between the unsigned number and the signed number. So if you don't know this, then please inform me. I will definitely make another video on this topic. Okay, so now coming to the architecture. So first instruction we have shift right. So this is the command shr, shift right. So what it will do, it will just perform the shift operation to the in the register, and we need to specify the number of bits that needs to be shipped. So the instruction will be your command, then your register name. Suppose we have a register and the register name is ax, and we need to shift this suppose 2 times. So this will be the command. And now I am drawing a diagram, and then you will be understand that how this actually happens. So let us take an example. suppose we have this is AX, our register, and this is 8-bit register, 1 2 3 4 5 6 7 8. Okay, and we have the data like 0 1 0 0 0 1 1 0, and I need to shift this two times to right. So whenever you are performing any shift operation, you need to understand very clearly that you need a carry flag, because this carry flag will store the bits that to be shifted, because otherwise we cannot have the track of the which bit has been shifted. So if we perform the right shift operation, then the carry flag will be on your right side, and if you perform the left shift operation, that time carry flag will be on your left side. So now I am performing right shift operation, so this is our carry flag, and we can uh, denote this by CF, carry flag. Okay, so now this is shift right, and this shift right is actually logical shift, and because for arithmetic shift we have another instruction. So this is, you remember, this is for logical shift operation. Now I am performing this two times. So if we perform this two times, then what will happen, this at first this 0 will come here, and all the bit will shift in the right side eventually. And if we again perform another, because we need to perform this two times, so what will happen, at first this 0 will come here, then this 1 will come here. So the after the operation, our register will look like this: 1 2 3 4 5 6 7 8, and this carry flag. So this 1 will come here, okay, no problem, and then this 1 will come here, this 0 will come here, this 0 will come here, this 0 will come here, this 1 will come here, this 0 will come here, and we need to fill these two empty places by 0. Okay, this is applies for logical right shift or logical shift. If we have any empty places, please fill this with 0. Okay, now I am coming to the next operation, that arithmetic right shift. This is logical right shift, and then the next operation is arithmetic right shift, then, and the syntax will be SAR, shift arithmetic right, and the and other two parameters will be same. Your, suppose this time I'm taking BX, and this is the register name, and I also want to shift this two time. Okay, so again I am taking the register as 8-bit register, 1 2 3 4 5 6 7 8. Okay, and I have a carry flag CF, and this is BX register. Okay, now I am filling this, right, I am filling this 1 0 0 1 1 1 0 1, and again I need to shift this two times. But remember, this is arithmetic shift, and what I have performed earlier, this is logical shift. And what is the difference between them? In logical shift is performed on unsigned number, and arithmetic shift performed on signed number. So actually what you can see here, this is a 1, this is a negative number. So when you want to shift this operation, we need to do the sign extension. What is sign extension? Sign extension means when we want to shift this to the right side, then what will happen, our most significant bit we need to preserve. So if it is 0, then we need to fill this place with 0, and if it is 1, then we need to fill this place with 1. This is the main difference between logical shift and arithmetic shift. In arithmetic shift, we need to perform the sign extension. So okay, I am doing this again. So we need to shift this two times, no problem. This 1 will come here at first, then this 0 will come here. So I am just writing the actual output here. This will be the carry flag. So this 0 will come here, and this 1 will come here, this one will come here, this one will come here, this 0 will come here, this 0 will come here, this one will come here, and we need to fill this place. So how we will fill? We will need to fill this by 1, because 1 is our most significant bit. If it is 0, then we need to fill this by 0. In this way, if you convert this to decimal number, then we will understand that actually we have this is a signed number, and actually we have already divided it by 4 because 2 times we have shift this arithmetic shift. Okay, now coming to the third point, I'm not discussing the shift right left again, because that will be same. Okay, but I need to discuss the shift arithmetic left, because in shift arithmetic left we are not preserving anything like this, because in the left side when you perform all those things. Okay, let me take the example. So we have shift left, that is logical shift, and we have shift arithmetic left. Okay, and now this time I am taking it is as dx, and also I'm doing this 2 times. And for this example I am not showing you, but let us consider that it is cx. Okay, now I'm doing this for this arithmetic left. Okay, so I have this 2 3 4 5 6 7 8. Okay, and this is dx. Okay, and I need to fill this with any number like 0 0 0 1 1 1 0 1. Okay, and this time what I told you earlier, if you are performing right shift, then your carry flag will be on your right, and if you are performing left shift, then your carry flag will be on your left. So this time our carry flag will be here, so I need to shift this 2 times. So what I will do, at first this 0 will come here, then this 0 will come here, so our output will be this cf, and this output will 0 will come here, 1 2 3 4 5 6 7 8. Okay, so this 0 will come here, this 1 will come here, 1 will come here, 1 will come here, 0 will come here, 1 will come here, and this empty places we need to fill this by 0, because in case of left shift, left arithmetic shift, or any type of left shift, we don't need to do anything like this sign extension. Okay, now we have some rotate operation. So before starting the rotate operation, I need to tell you very little thing about this, about the logical shift and this shift operation, rotation operation. What happens in case of shift operations, they have some mathematical foundation, because we are actually performing the division or multiplication by 2, but the rotate operation does not have any mathematical foundation. So you need to consider this in your mind. Okay, because this rotate operation actually depends upon your algorithm, that what you are performing. Sometimes you need to rotate, or you don't need to rotate, because they don't have any mathematical foundation. Always keep this in mind. Okay, so I'm just showing you one example. Okay, so this is fifth instruction, rotate left. Okay, and the parameter will be same. Suppose it is ex, our register name, and I need to rotate this 2 times. Okay, so rotate is basically same, because what we have done earlier in case of shift operation, we are actually shift all the bits to the carry flag, and but in rotate operation what we will do, we will actually rotate this bit to our on the other end. Okay, so let me take an example. So this is left shift, and our carry flag will be here, cf 1 2 3 4 5 6 7 8. Okay, and this is our EX. Okay, so let me take any example. Suppose 1 1 1 1 0 0 1 0. Okay, now I need to rotate left. Okay, rotate left 2 times. So then what it will, what we have, at first this one will come here, also this one will also go here, because this rotate operation will be like this, rotate. Okay, so this one will come here, and eventually it will also go to the left end, because we are not discarding any bit here, because in the earlier operations you have seen that we have discarded some bits, but here actually you are not discarding any bits. We are just uh, keeping a track of this, like in the rotate operation, one will come here, then this one will come here. So what will be our output? At first this one will come here, then this one will again come here, and also at first this one will come here in the carry flag, and then when the next one come here, then the first one will get discarded. So our output will be like 1, because this one will come here, and our register will be like 1 2 3 4 5 6 7 8. Okay, our register will like this one will come here, this one will come here, and other things you just need to just place them as it is, 1 1. So this will be the rotate left operation, and in the same way you can do the rotate right operation. So I am not showing it here. We have this rotate right operation. Suppose that is for fx and do for 2 bits. Okay, so this thing you can also do by yourself, no need to worry. Okay, and there is another thing, that is rotate with carry. Rotate with carry left. This is only rotate left, and we have rotate carry left. So what is this rotate carry left? So let me take an example. Rotate carry left, and then it will also take 2 parameters. Suppose it is gx to, we are shifting this 2 bits. Okay, so now for left, so we will have our carry flag here, and we will have our register 1 2 3 4 5 6 7 8. Okay, and this is our register. So fill this randomly, 0 1 0 1 1 1 0 0. Okay, so this time we need to rotate with carry. So this is little difference between the earlier operation. In the earlier operation, what we have done, we have discarded one carry here. You can remember, when I at first I have shift this one to the carry, and then when I again shift this one to the carry flag, that time the first one get discarded. But here actually you are not discarding anything. So here we just need to totally rotate the register with the help of this carry flag. So if I perform this operation here again, you can see here we need to do this 2 times. Okay, 2 times we need to shift this, but with the help of this carry flag. So at first what will happen, at first this 0 will come here, and then this 1 will come here. Okay, and when this 0 will come here, so initially suppose this carry flag will have a 0 by default, because it does not have anything, means it has 0. So that this 0 will go to the end. Okay, so our output will become like this, carry flag 1 2 3 4 5 6 7 8. Okay, okay, so at first this 0 will come here, and in the same time this 0 will come here, and what will happen in the next iteration, this 0 will come also here, so it will have 2 zeros in the end, and this 1 will come here. So again I am discussing 0 1, so this 1 will come here, and this 0 will come, this is the first 0, and this is the 0 in our register, and you need to fill the other bits as it is, 0 0 1 1 0 0 1 1 1. Okay, I have taken more bits here. Okay, 1 2 3 4 5 6 7 8. Okay, 0 0 1 1 1 and 0. Okay, so 0 1 1 1 0 0 0 0 0 1 1 1 0 0 0 0. The by this way you need to rotate with carry, so it is rotate carry left. And so in that way we will also have another operation with eighth operation, rotate carry right, and suppose this is hx and 2. So you can also do this by yourself. Just take the carry flag in the right side and do the same operation. And as this time you do not need to do anything like this, what you have do it earlier. That means the sign extension, because this time you don't need to do any sign extension, because your carry flag will come to the end, because you are rotating with carry. So no need to perform carry sign extension. And also there is also one difference between why we do not need to perform this sign extension, because earlier I have told you that this shift operation have some mathematical foundation, and this rotate operation does not have any mathematical foundation. So this rotate operation you can apply on unsigned number as well as signed number or any other type of numbers. But in shift operations, if you have this logical shift, that time you need to do this on unsigned number, and if you have this arithmetic shift, then you need to do this on your signed number. Okay, so in this way we need to perform those things. Okay, and if you have any doubt you can comment on this video section. Okay, so thank you guys, and I hope it will be helpful to understand. Okay, thank you.